Okay, any ideas to this problem? Uh, let's explain first. So basically, you are given n integers, an array of n integers, and you are able to modify each element such that you can increase each element by one. Okay. Um, so what's the minimum number of steps required to make this array increasing? For example, let's take this example here. We have three. No. Okay. We have 3, 2, 5, 1, 7. And we are able, at each step, we can increase any element by 1. That's it. Actually, you can only increase, right? You may increase value of any element by 1. We want to know the minimum number of turns required to make it increasing. So here, it's clear what should we make. We should increase the 2 by 1, so it will be 3. So now we have done one operation. And then this is increasing, right? But 1 is not greater than this. So we'll increase 1 by 4. It should be 5. So increasing means that it's not decreasing. Okay? It's not exactly increasing. So it's not decreasing. So it's sorted in ascending order. Okay? So now we have 5 steps. Yes, and the answer is 5. So we had 5 steps to make this array increasing. Let's take another example. Let's say, for example, I have 9, 8, 7, 8, 5, 6, 5, 4, 3, 2, 1. For this to be increasing, it's clear that we will make the first element, which is 5, is the greatest thing in the array. So we want to make all the elements after 5 is greater than or equals to 5, right? So we'll make this 4 equals to 5, this 3 equals to 5, this 2 equals to 5, this 1 equals to 5, okay? And then count the number of steps we have done that, okay? So it will be 1 plus 2 plus 3 plus 4. It will be 10 steps, okay? This is what the problem says. Do you have any ideas how could we approach this?
We could traverse the array and check whether the previous element is lesser. If it's lesser, then we'll subtract those two elements, get the difference, and add it to the count. So this will continue until the last element.
Yes, you're right. But actually, you mean if the previous element is greater than, not smaller than, right?
Yeah. So then we'll get the difference of the two.
Okay, so that's it. This should be an easy problem. So we'll make, as you said, we'll take n, and we'll make the array of n. We'll take every element. So to make this this problem will pass, and it will be okay if I made an array. But to make it memory efficient, we can make it with order of 1 memory complexity. Okay, because we're only caring about the previous element at each position I'm standing at. So I don't care about the whole array. So I just store one variable called last element, and it will be initially 0. And then after I take a new element, then I'll update last with this element. So for example, so last initially will be equals to 0. And then after I take 6 from the input, then I'll make last equals to 6. And then I'm standing at 7 now, so I can check now if the current position and the last is greater or smaller. Okay, and then I'll update last to 7 and 6 and 5 and 4 and so on. So this will make the memory complexity of 1. Um, so I'll traverse n times. I'll go n times. While n minus minus. I'll take the integer. So first, as you said, I will check if x is greater than last, then I'm okay. If it's smaller than last, then I want to add to the answer the difference between them. So answer equals to 0. So now I'll just make this uh, answer plus equals max. I'll make it easier with if else things. Okay. If x is smaller than last, then s plus equals last minus x. Okay. So now, what does that mean? I've increased x by the difference between it and the last. So if last is 3 or 10, and now I'm standing at 7, then x is smaller than last. So I will increase 7 by the difference between them. So I'll increase 7 by 3 and add, I'll increase 7 by 3 and I'll make it 10 and add to the answer 3. Okay? So now I'll increase, I'll update last. But you may say that I'll update last by x, but that's not true. I'll update last by the maximum between x and last. Okay, so last will be, if last is greater than x, so it will be as it is, last. If it's smaller than x, then I'll make it x. Okay, that's it. Because if for example, last was okay, I don't have an example here. If last is something like, actually x is greater than or equals to last, so last will be equals to only x. Yes, that's true. Okay, last equals to x. So now we'll print the answer, but we want to there is a case. So x is up to 10 power 9 and n is up to 10 power 5. So the answer could go up to 10 power 9 times 10 power 5 times 2 times 10 power 5, which is long. So answer shouldn't be integer. Okay, that's it. Let's run. 5. Okay. I'll make it small. Okay, let's select. Oh, there is a bug. Okay, there might be a small bug here. Let's check this. Yes, I didn't update x. So x should be equals to last here. So after I increased x by the difference between them, so actually x should be equals to last. Okay, that's it. Okay. Okay. Let's give you the code here. Okay, I sent the code here at the chat. Let's go to another problem. Okay, let's see this problem. I sent you the link of this problem here in the chat. Take 3 minutes to read it. Okay. Okay, any ideas how to solve this problem? Any ideas? Uh, okay, let's explain first. Your task is to count the number of ways to construct some n by throwing the dice once or more times. Each throw produces an outcome between 1 and 6. So now, so you are throwing a dice, and at each time it produces an outcome between 1 and 6. So what are the number of ways to get the sum of n by throwing the dice multiple times? So for example, for n equals to 3, I could throw the dice thrice, 3 times, to get 1, and then the second time 1, and then the third time 1, and I'll get the sum of 3. And I could throw the dice the first time and get 1, the second time get 2. Then I could throw it and first time get 2, the second game get 1, and then I could throw it and get 3 at the first time. So there are 4 ways that I can get a sum of 3 after throwing the dice. Okay, so given n, and n is large, is up to 10 power 6. I want to count the number of ways to construct n with numbers from 1 to 6 actually. Okay, so for example, so for example 4, I could make 1 1 1 1, or I could make 1 2 1, or 1 2 or 1 1 2, or 2 2, and there are many ways. Okay, so one observation is that we could get okay, one observation is that we could get the answer of 4 from the answer of 3. How is that? We know that the answer of 3 is 4. We have 4 ways. So answer of 3 equals 4. So to construct 4, I could add 1. I could throw the dice once and get 1, and then the answer of 3, and then get the answer of 3, because so answer of 4 will be equal to answer of 3 if we threw the first time 1. So if we throw 1 at the first time, and then we get the answer of 3, which is 4, then answer of 4 will be equals to answer of 3 one time, and then if we threw 2, then answer of 4 will be equals to 4 minus 2, which is answer of 2, and then if we threw 3 the first time, we could get if we threw 3 the first time, then we could get the answer for 4. We could add to it the answer for 1, right? And also we will add 1 to all of this because we could throw 4 the first time. Okay, so for example, if we have n, and n is very big, let's leave it n. So the answer for n will be the sum. So let's make it clearer here. So if I want to get the answer of n, so if I threw 1 the first time, then I could get I could add the answer of n minus 1, because if I threw 1 the first time, then one could combine with all the answers of n minus 1 to form n, right? Because the answer for n minus 1 equals to the number of ways to form n minus 1. So if I threw 1 the first time, then I could get the answer for n minus 1, and then add to it 1, and it will be n. Okay, so the answer for n will be equals to ans of if I threw 1 the first time, so it will be n minus 1 plus ans of n minus 2 plus ans of n minus 3 plus ans of n minus 4 plus ans of n minus 5 plus ans of n minus 6. That's it. And of course, given that n is greater than 6, of course, because if n is 4, then I'll just answer 3 plus answer 2 plus answer 1 plus 1, which is throwing 4 from the first time. Okay, so that's it. So this is actually a DP approach. It could be solved only using DP for now. We are getting the answer for every n from the answers of the previous n's. Okay, any question?
Yeah, can you please explain why we are adding +1 one more time?
Okay, so now I said now that to get the answer for 4, I could throw 1 the first time, and then get the answer for 3. So let's here, if I throw 1, okay, if I throw 1, I could get the answer for 3 and then add it, and if I throw 2, then I could get the answer for 2, and then this will be 4. and then if I threw 3, then I could add the answer of 1. But if I threw 4, so if I throw 4, then the answer for 0, the answer for 0 is 1. So if I threw 4, then I just, this is one way. So one way of getting 4 from throwing 4 is 1 actually, right? So I have 1. The same like the answer for 1. So what's the answer for 1? What do you think the answer for 1? So for n equals 1, it should be 1. So the answer for n equal 1 is throwing the dice once and getting the value 1. Okay? And the answer for 2, it will actually be 3. Why is that? It will be answer for 1. Actually, 1 plus 1. Yes, it will be 2. So answer for 2 will be the answer for 1 plus 1. So throwing 1 and then get the answer for 1, and then throwing 2. Okay? Did you get now why you are adding 1? So we are adding 1 only for the first 6 values. So answer for 5 and answer for 6. Okay?
Yes.
Okay. So as I said here, this is dp of complexity n times 6, which is n of n, because we are getting the answer for every n from the answer of every previous n's. That's it. We could make it using top-down approach or bottom-up approach, recursion or iterative. I'll make it an iterative way, should be easier. So first I'm given n, and then I'll make an array called dp. Just make it answer to make it easier. So I'm saying answer of n plus 1, okay, because it's 0 based in this. So I want first to initialize answer of 0 with 1. What does that mean? So as I said here, ans of 3 equals ans of 2 plus ans of 1 plus 1, okay? So plus 1 means that I just throw 3 and then getting the answer of 0, which is nothing. So this will be 1. So I want to first initialize, just to make it easier in the code, initialize answer of 0 is 1, and then not adding 1 here, but actually adding answer of 0. So for each integer that's smaller than or equals to 6, I'll just add the answer for its previous element until 0. Okay, that's it. Instead of initializing answer of 1 with 1, I'm initializing answer of 0 with 1, and then getting all the answers from 0.
But if you are getting 1, then it will be 1 plus answer of 0, then it will be 2. That's not right.
No, why is that? So answer of 1 will be answer of 1 minus 1, which is answer of 0. That's it. Because I'm saying that answer of 3 equals answer of 3 minus 1, which is 2, plus answer of 1. So I'm just subtracting 1, okay?
Okay, yeah.
Okay. So I'll loop from 1 to n, and then getting the answers from 1 up till n, this way, okay? So I'm saying for int I equals 1 smaller than or equals 10 I plus plus. So I want to make a second loop for getting the answers for the previous elements, and this loop will go only 6 times, and start from j equals 1 to j smaller than or equals to 6 j plus plus, okay? And then answer of I will actually plus. So I want to not plus plus, to be plus equals to answer of I minus j. Okay, so first time answer of I, I'll add to it answer of I minus 1, then I minus 2 until I minus 6. But what if I is more than or equal to 6? Then answer of I minus j will go negative. So 5 minus 6, for example, will be negative 1. So I want to make here another condition that I minus j greater than or equals to 0. Okay, so if j is greater than I, then it won't continue this loop. Okay, and that's it. And that's the answer actually. And then I print answer of n. let's try this. But okay, let's try 3. Okay, 3 gave us 4. But there is one thing that since the answer could be very large, so the answer won't fit any data type. It will be a big integer. So I'll print the answer modulo 10 power 9 plus 7. So I cannot print answer of n modulo 10 power 9 plus 7, 1e7, because actually if I calculated it this way, then answer of n won't store the real number because it won't fit any integer. Then I want to mod in each operation because modular is a distributive operation. Okay, so answer of I mod equal. I'll make here an integer called mod. And that's it. Let's try some values. So 1. Why it's so low? 2. Giving us 2. And 3. It's giving 4. Let's check for 4. 4s will be bigger. 8. Okay, let's check for very big value. Okay, so actually this value is modded by 10 power 9 plus 7. Okay. Any question in this DP? Any part that you didn't get? Any small part?
You can do that mod while storing itself, right? Here you're storing the value, then again you're modding that. That
yes.
may store it.
Okay, say yes. Continue. So what's the question?
Here in line number 15, here you're storing the it, right? So you can do the mod while storing itself. If it's a larger value, anyway it will overflow. Then doing a mod will not yield a good result.
So I didn't quite get you because your voice was going and coming. So you're saying that.
Okay, here in line number 15, the
Yes.
answer of I plus equals answer of I minus j. At that time only you can mod, because if it's a big number, that may not fit. So you're storing the number, then again in the next step you're removing the number, modding it, putting it back, right? So why can't we do it at that step itself?
At here? You mean
Yeah.
here?
Yeah.
So it's the same thing. So if I did it here, so I make it something like this: answer of I equals answer of I plus answer of I minus j mod. So this is what you mean? Or
Yes.
what?
Yes.
So this is okay. This is the same thing because I'm adding then applying the mod. So what I've done here is I added and then applied the mod. So it doesn't make any difference. Okay.
No, for example, when you added that, the number may be large enough which may not fit into answer of I.
Oh, yes, I got you. So this is a very good point, but note that the integer is up to 2 power 32, which is approximately something like 2e9 plus something. Okay, so actually 1e9, so mod times 2 will fit in an integer. Okay, so if I added if I have some value which is smaller than or equals to mod plus some value which is smaller than or equals to mod, which is here, so answer of I is more than mod, answer of I minus 1 is more than mod. So the sum of these two will be smaller than the integer, will fit in the integer. Okay, so I'm modding every time to make sure that they will not increase and they will not reach something like 3 times mod. Okay, so this will fit an integer type. Okay, but if mod was something like 2e9 plus 7, then actually I couldn't make I wouldn't be able to make all this operation in an integer type. Okay, I will only use long here if it's 2e9. Okay, did you get it?
Okay, yeah.
Okay.
But this is a dice problem, right? Like, so maximum we can give try for 6, right?
So what?
It is a dice problem, so the maximum number which we can try is 6, right?
Yes, yes, the maximum number which can try 6, which is here. So I'm just I'm looping from j equals 1 to j equals 6. So I'm getting the answer from I minus j because I'm throwing a die which is of a value from 1 to 6. So if j equals to 6, for example, then I'm throwing 6 and getting the number of ways to get n minus 6. Okay, did you get it?
Yeah, but so the input also can be 1 to 6 only, right? It cannot have a bigger number, no?
No, no. What's the relation between the number of ways to get? No, no. So the problem asks us to what's the number of ways to throw multiple dice and then getting the sum of the values getting from these dice to get n. So if I throw die once and get 6, and second time I get 6, and third time I get 6, then now I got 6 plus 6 plus 6, which is 18. So the question asks us if n is some value, what's the number of ways to throw multiple dice multiple times, and then after getting the sum of all of these values, uh, they approach n. So did you get it?
Yeah,
So
yeah,
for example,
yeah, correct.
okay,
Yes, yes.
okay. So that's it. Anyone want to ask another question for submitting? For you have to understand everything in this code. Okay, let's submit. Okay. Here I sent the link of the code in the chat. Let's go to another easy problem or that fits the time. Uh, okay, let's get to this problem. I sent the link here in the chat. Take 3 minutes to read it. Okay. Okay, let's explain the problem. So we are given a grid of size n times n, which has n times n squares, and some of these squares may have traps, and it's not allowed to move to a square with a trap. Okay, your task is to calculate the number of paths from the upper left square to the lower left square where you can only move right or down. Okay, so you are given a grid of size n times n, which contains of dots, or actually empty squares or traps. You can move through an empty square. Actually, how can you move? Yes, you can move from the upper left square to the lower right. Remember us. How can you move? Yes, you can move right or down only. So let's take an example here. If I have some grid like this, so if I'm standing here at the upper left square, so actually I'm standing here at the upper left square, and I want to get here at the lower right square. I can only move right or down, so one step right or one step down, but I cannot go into a trap. So the trap is where is the asterisk here, okay, and the dot is an empty square. So from this square I can go down here, or up here, or right here, okay. I can go right here or down here, and from this square I can go here or here, okay. So from this square I have two ways to to the next step, which is here and here, and for this I have one way only, which is this, which is the right square here. I cannot go down, okay. So at each step I can only go right or down, and I cannot go to a trap square, okay. That's it. And I want to count the number of ways, so the number of paths. So I could go, for example, one path like this. Let's make spaces here. Okay, this is clear. So if I'm starting from here, one path could be something like this. I start from here, and then go here, and then go here, then go here, then go here, and then here, and then reach here. This is one path. But another path could be something like this. So the same thing, but instead of going here, I could go here, for example, and then go here, and then go here. Or I could go from up. I could go here, and then here, and then here. So I have many ways I can reach this lower right corner. How could we do this? Yes,
We can go by a recursive call by right and down. So whenever we reach a star, we'll return 0. Otherwise,
okay.
if we reach the end, we'll return 1. So we'll count how many times we reach that end.
Okay, so what are the transitions? So now you said only the base case that will return 0 or 1.
Yeah. Yeah,
What are the
transitions are, if you're taking x and y, it will be x comma y plus 1, or x plus 1 comma y. So to the right or to the bottom. And the base case would be we are not exceeding that x and y boundaries.
Yes, actually you're right. So for the transitions, we are adding the call of the right to the call to the left. So I'm getting, okay. So do you all understand this? Did you get this? So what we'll actually do is, if I'm standing at n square, so recursion is the easier way, but we can do it with iterative. I'll do it with two ways now. But if I'm standing at n square, um I can go right or down. So I can make a recursion call to calculate to the answer for this square equals to the answer of going to the right square plus the answer of going to the left square. And if I reach a trap, then I'll return 0, and if I reach the end, I'll return 1. That's it. Okay. So what do you think the complexity of this algorithm? Uh, u who
O of n into m, x into y. So,
u of n times n. So you're saying that we'll do this. Okay, just stay with me. Okay, and solve. So x and y, it will be I and j. Okay, representing the rows and columns. So you're saying that if I equals to n and j equals to m, so I have here int n, then I return 1, right?
yes.
And if actually I want to have a Boolean function that checks for the bounds of I and j to make sure that they are within n and m. Okay, so I return I greater than or equals to 0 and j greater than or equals to 0 and I smaller than n and j smaller than n. Okay. Okay. So I want first to check if this is if this is boundaries. Okay. So if check I and j, so if it's within the matrix, if check I and j, and let's make a character matrix. Right. And m is up to 10 power 3. Okay. So I here check if mat of I of j equals to trap, then I return 0. So these are the two base cases. So if I'm at a trap, I return 0. But first,
Now in check
I would,
also I should be lesser than or equal to n and j lesser than or equal to m, right? So if it's equal to, then if it's equal to m, that will not come to the second if statement at all, right? It will return over there,
uh,
right?
yes, you're right. So I could not lesser or equal, I make it -1. So if I equals to n minus 1 and j equals to n minus 1. So
Oh yeah.
because the end is at n minus 1, n minus 1. Okay. But here there's uh, okay, actually I need to separate this check because I want to return 0 if not check I and j. Okay, return 0. And I could make this in the same if, but I'm saying if not check I and j or met ij. So if it's not in the matrix, then I return 0. But if it's at the matrix and I am at a trap, then I return 0. Otherwise, I'll check and then return 1 if I am at the end. And you're saying now that the transitions are, I just return solve, solve I plus 1j plus solve ij plus 1, right? And the complexity, you're saying it is n part 2. But you forgot about something. So we should make this. We should make memoization to make this dynamic programming, because this is just a recursive calls that will go exponentially. So the complexity for this function is exactly two what's two power n squared. So that's very big. Okay. So because at each cell I'm going I'm calling the function 2 times. So it will be 2 power n squared. So this will not pass. So I want to make memoization here, right? So did you get this, the complexity of this?
Oh yeah, that's
Okay. Okay, so I want to store the answer for every I and j, because if I pass through it, then I won't pass again. So I make memo of m and then I'll just check here if memo of ij equals -1. This will be R, okay. If R equals, so R is storing the value of memo of I of j, and it's taking a reference to it. So if R equals to -1, then I didn't pass through this cell before. Then I'll just return solve I plus 1 j plus solve I j plus 1. But there is something here. Okay. Otherwise, I'll just return R. Let's try this. First, I'll take the inputs. Actually, this is not n and m, this is only n. Okay. And then I want to memset the memo array to -1, size of memo. And then I'll just print solve 0 0. Okay, this should be fine. What's this? Yes, it's the asterisk, not this. Okay, now it's 3. So now this recursive approach is easier to think about it, but there are a lot of code. So I prefer to make a bottom-up approach using only recursive codes. Okay, so we'll not use all of this. Let's delete all of this, and then write a simple code that will solve it using recursive codes. So how is that? So let's look at the example here. So to get the answer for the last cell, so now for the recursive, we started for the recursion approach, we're starting from the first cell. But now here we will start calculating from the last cell, okay? So the answer for the last cell will be 1, okay? That's it. The answer for the last cell will be, if I started from the last cell, the number of passes from the last cell to the last cell is 1, okay? And if I have gone left, so the answer for this is actually 1, because I could only get from this cell to the last cell with 1 pass. But if I'm here at this cell, so the answer will be the answer, like I calculated up here. So the answer of this cell will be the answer of this cell plus the answer of this cell. Okay, so I'm just calculating from the bottom to up. Okay, so here I'll take n, and then I'll make matrix of size n times n, and then I'll make an integer answer. Okay, integer ans of n that will store the answer for each cell, and then I'll make mod equals 1e9 plus 7. So now I'll take again. Why I deleted it? Sin match of 5j. So now after taking the input, I want to calculate the answer array, but starting from the last cell. Okay, so I'll start from I equals to n minus 1, of course. I greater than or equals to 0, I minus minus. And for int j equals to n minus 1, j greater than or equals to 0, j minus minus. So not to make things go out of bounds, so So now here I want to calculate ans of I of j equals to ans of I plus 1 j plus ans I j plus 1, right? But if I'm standing here at the last cell, then answer of I plus 1 and j plus 1, I'm getting out of the bounds, right? Because there are no cells here. So I want to add another empty row here that's containing of zeros, for example, just to make use of this row when using the last row or the last column. Okay, it will not contribute to the answer, and this is not important, but I'll add. So here, when I'm calculating the answer for any cell that's at the boundary points, then I'm taking the values of the next right cell and the next down cell. So I'll take zero with me, which is not in the matrix. Okay. So I'll just add an extra row and an extra column. That's it. And I want to initialize this with 0. Okay. Yes, that should be it. And the answer should be ans of 0 of 0. So this code is way easier than the recursion code, actually way shorter. Okay. So that's it. But I don't want to forget about the mod. So I make again ans ij mod equals to mod. That's it. Let's give us 0. Yes. Yes, actually, this will make everything equals to 0. So I want to make. Yes, I have multiple checks to make. First, if mat of I of j equals to dot, I want to calculate the answer for it, right? But I want to for these extra columns, for this extra column a row, I want to add 1, not 0. Why? Because the answer for this, actually, not the two of them are 1s. Okay, so I'll make the two of them 0s and then make the answer for every I and j equals to max either this or 1. Why is this? Because I'll explain it now. So now here, if I'm standing at the last cell, so I'm getting the answer from the next right and the next down, but this will be 0. So I'm calculating everything is 0. So if I'm calculating the answer to any cell and I found that it is 0, then I'll add 1. Okay, but actually, I'll make one thing. I'll initialize the last cell with 0 if it's asterisk. Okay, so if mat of n minus 1 of n minus 1 equal to asterisk, then I know that the answer for it is 1, right? Then answer of n minus 1 of n minus 1 equals to 1. And then I don't have to make this maximum thing. So then here everything should be okay. So this will be initialized with 1, and this will be updated according to this, to the last element. Okay. Hope this works. Again. Actually, if it's dot, why asterisk? If it's empty, of course. Sum equals to dot. Sum equal to 1. Yes. So here I'm initializing the last cell with 1, but I'm also passing through it and then putting it 0 again. So I don't want to pass through the last cell again. So I'll make it mass. Let's try this and I'll tell you what it does now. Okay, so what I did now is I took the maximum between the answer of this cell and calculating the answer for this cell from the right and down cell. Because I initialized the last cell with 1, so I don't want to set it with 0 again. So if I found that the answer for this cell is greater than calculating the right and the down, then I'll just take the maximum of it, which is the answer for this cell. Actually, this line of code will be benefit only to this last cell, n-1 and n-1, because at any other cell, answer of I of j will initially be 0. Okay, so it will always calculate the new value for it. Okay. Okay, let's submit it. Okay. Okay, here's the code. Okay, I sent the code here at the chat, and I finished today. I want to give you a homework problem, and I hope you solve it as well. Let me choose to. Okay, this is a good problem. So this is the homework problem. I sent it to you in the chat here. Try to solve it as hard as you can, and we'll discuss it next time. Okay. Thank you. Bye. Do you have any questions before I leave?
No, thank you.
Okay.
Thank you.
Thank you.
Okay, thanks. Bye.